Physics, but simple. Electric charge is something we experience almost every day, even if we don't always notice it. From tiny sparks to sudden static shocks, it quietly shapes how objects interact around us. Sometimes, the most interesting physics begins with simple questions, like why we feel a small shock when touching a metal object, or why a comb can suddenly attract tiny pieces of paper after being rubbed. Physics really does love turning everyday moments into mysteries. To understand this, we need to look deeper inside the atom, the basic building block of matter. At this level, electric charge appears as a fundamental property. There are two types: positive charges carried by protons and negative charges carried by electrons. These charges interact in very predictable ways. Similar charges like positive with positive or negative with negative repel each other, pushing apart. But opposite charges, positive and negative, attract, pulling toward one another. It's like they just can't stay away from each other. Inside an atom, positively charged protons are packed in the nucleus, while negatively charged electrons move around it. Most of the time, these charges balance out, making the atom electrically neutral. Everything is calm, everything is stable, until electrons decide to move. And yes, they will move. When objects are rubbed together, electrons can transfer from one material to another. This creates an imbalance, and suddenly, objects are no longer neutral. They become electrically charged. So that tiny shock you feel, that's just electrons being a little dramatic. Once charges are free to move, their behavior depends on the material. In conductors, like metals, electrons can move freely, flowing through the structure with every little resistance. That's why metals are used in wires and electrical systems. In contrast, insulators like plastic, rubber, or wood hold their electrons tightly. Chargers don't move easily, so they tend to stay exactly where they are. In simple terms, conductors let charges flow, insulators keep them stuck. Now, how do objects actually become charged? One common method is conduction. This happens when a charged object comes into direct contact with a neutral one. As they touch, electrons transfer directly between them, and the neutral object becomes charged as well. Another method is induction, which is slightly more interesting because it doesn't require contact at all. A charged object brought nearby can cause charges inside another object to rearrange. No touching, but still an effect. To detect whether an object is charged, we can use a device called an electroscope. When charge is present, the leaves inside acquire the same type of charge and begin to repel each other, spreading apart. It's a simple but powerful way to see something that's otherwise invisible. All of these behaviors follow a few fundamental rules. One of the most important is Coulomb's law, which describes the force between two charges. The bigger the charges, the stronger the force between them. So if you double the charge, the force increases as well. More charge, more interaction. Simple. But electric charge has another interesting property. It is quantized. This means charge doesn't exist in just any value, but only in specific amounts. Every charge you see is actually a multiple of a single fundamental unit, the charge of one electron. So, no matter how complex things look, everything is built from these tiny, consistent pieces. And finally, one of the most important ideas: charge is always conserved. It cannot be created or destroyed, only transferred from one object to another. Before and after any interaction, the total charge remains the same. It just moves around, redistributing itself. Nothing is lost, nothing is gained, just rearranged. So, if charge is always conserved, what does that mean for the universe? It means that every interaction, every spark, every tiny shock is part of a much big a balance that is constantly maintained. And once you start to notice it, you realize these tiny interactions are happening everywhere, all the time. That's electric charge. Physics, but simple.